I'm Strawberry Bird, and I'm Hugh Lovel's wife, and I'm also the widow of Christopher Bird, who wrote Secret Life of Plants and Secrets of the Soil. And I've been immersed in this biodynamics 33 years. But I'm not immersed like Hugh. So we were next door neighbors for 32 years in the North Georgia mountains, and he immigrated to Australia. I guess you read all this stuff, so you don't need me to tell you. But we're so honored that you're here. We're so honored that you take it on to have your soil produce the most nutritionally dense food. And so I'm just going to, are you ready, Hugh? Now he's signing something, so we'll just go on. And please write your questions down. He loves questions. We're starting a webinar series where you can ask your questions on the webinar, either through a phone or a computer. And it's like having a class, 2-hour class where you could ask questions. Hugh does a lot of phone consulting for farmers, and a lot of dairy farmers are coming these days. So now are you ready? Okay. So this is Hugh Lovel.
Let's see if this mic works properly. I may have to talk down here on the floor at floor level. Is that going to be okay with people, I wonder? Because I probably want to point at things. I don't have a laser pointer, so one bit of technology missing. But yeah, I wanted to say this slide presentation, and you can go ahead and click it. This slide presentation, which is about biodynamic preparations, will be available on CD at our table tomorrow. So we'll have like a free exhibitors table outside here tomorrow, and we will have these CDs available, and they've got notes down underneath, not this one, but there's another note written down in the slide in PowerPoint, and it'll be on both PowerPoint and in Adobe PDF, so you can play it on any kind of a computer. Now, I've got here in this picture just a few images associated with biodynamic agriculture, and at the core of what biodynamic means, because it means life processes, biodynamic. And it's an agriculture that's unique amongst any other form of agriculture by focusing on improving and enhancing life processes. So, one of the interesting things about life is it arises at boundaries. In chaos theory, there's no theory that there's chaos. Chaos exists. But why is it that order arises with chaos? And it always arises at boundaries. Now, one of the interesting things about mathematics, and I had a great deal of trouble with this when I studied biochemistry, was equalities didn't make any sense to me at all. My upbringing, we 3 kids, anytime we divided something, whoever got the job of dividing it got last choice, because we knew the pieces were never equal. There is no such thing as equality in the universe. But mathematics, I found, this is what made the difference for me in mathematics and made it possible for me to study mathematics, because I couldn't make any sense out of equalities. And we had something called, in my 3rd unit in algebra, after flunking the first 2, we had something called axioms and theorems and proofs. And the equality axiom is a statement. An axiom is a statement that's taken as true, even though it can't be proven, and probably is false. But you have to pretend as though it's true. So it's a statement that's taken as true and can't be proven. And the equality axiom is that sort of thing in mathematics. And so mathematics is an ideal system. It's not actually, it's not a real system. It's not what we think of as the world around us.
You're getting a little
Yeah, I'm getting a little feedback.
I think maybe your mic is not that high. What? Higher up.
Yeah.
Right, yeah. It's a
Okay,
ringing.
so,
Is that
yeah, I've
better?
been hearing
Let's
it
just
too.
try it first. Is that better sound?
It's okay.
All right,
This is a picture of the Mandelbrot set. And the Mandelbrot set is generated by defining boundaries. And you take the equation, which, as I say, is an ideal sort of a concept, of z is equal to z squared plus c. In Australia, we call that z. Z is equal to z squared plus c. And z is a variable that you can plug in any value to, and c is a constant. And you generate a lot of different points, and you end up with this incredibly complex that you can look at level after level of refinement, and you get these beautiful pictures. And it's called fractal geometry. And what we see in the world around us, particularly in biological systems, is we see this fractal behavior created by looking at boundary phenomena. It's boundaries that give rise to life. Now, we're all carbon-based life forms, and biodynamic agriculture improves and enhances carbon capture. So let me talk a little bit about this picture. This was taken only about a week ago. A mate of mine in Theodore, Queensland, is growing this. I gave him some seed out of my breeding program it was a couple of years ago. And he's grown it out in his garden. And he uses biodynamic preparations. He doesn't use fertilizers. Now, he's had a small amount of composting and mulching. You'll see in the foreground there's some hay mulch on the soil. But he also grows weeds in his garden. And if you look at the size of the corn stalks, I put a little picture in the corner here that shows the root development of the corn plant. And there's 3 layers of brace roots coming out on the corn stalk above the surface of the soil. But the first one's coming out just barely above the surface of the soil. It's an interesting characteristic because you're not feeding any nitrogen fertilizers, particularly the nitrogen. You actually want to keep all soluble nutrient levels low. Weeds developed to scavenge up soluble nutrients. So they don't come with their own food package to get the soil biology cooking on their roots. They rely on scavenging where there's a surplus. So if you want to grow weeds in your garden, get high levels of soluble nutrients in your soil. But they will be the waste products of the microorganisms that would otherwise make those nutrients available from insoluble reserves. And humic acid molecules are big carbon molecules that tie up loose nutrients in insoluble but available forms. So you want to keep the soil alive, but you need those scavengers there to clean up any excesses of soluble nutrients. And so the corn there, not having the soluble nutrients, from there to its next leaf node was actually very short distance. And then, as it got the soil biology cooking, then it got to be a greater distance between the leaf nodes, because what's going on with the corn plant is it's very efficient photosynthesizer, and it's sending an abundance of sugars to the roots, carbohydrates. And this feeds the microbes in the zone around the roots that's only about 3/8 of an inch in diameter. in radius. And that creates a zone of very rich, very energy-rich, and very populous microbial activity. And the microbes that fix nitrogen out of the atmosphere require a lot of energy to do this. Now, they'll also require the availability of nutrients such as calcium. But they have to have a lot of energy. It takes 10 units of sugar to make 1 unit of amino acid. And it's also true, though, that if the plant took up its nitrogen as nitrates into the leaf, it again takes almost 10 units of sugar to convert nitrate into amino acid. So it's really better if the corn is feeding this process along the roots. And you have then these nitrogen-fixing microbes growing in great abundance. Guess what? They don't give their nitrogen to the corn plant. Something like protozoa, mites, nematodes, earthworms, ants, they have to come along and eat those microbes and digest them, and they will excrete around 95% of the amino acids as freshly digested amino acids. And then the corn plant has those right there at the roots where it takes them up within hours, and it's getting its nitrogen as amino acid nitrogen instead of nitrate. The amino acids don't have a chance to oxidize before the corn plant has taken them up. And when that happens, it's just an assembly process of its proteins, chlorophyll being chief amongst those. So its cell division, its DNA, all of the protein chemistry of the plant is fed by amino acid nitrogen, and then you can grow a corn plant that has a stalk this thick. And this is just barely tasseling, and it's going to get 3 or 4 feet higher before it's finished. So it makes an ear of corn that would go from the inside of my elbow to the end of at my wrist and fill out to the last kernel on the tip. And you cannot do this with chemical fertilizer. The only way I've ever seen this done is with biodynamic preparations. So I wanted you to get a rather dramatic view of what's possible with biodynamic preparations. The whole idea in biodynamics is that the farm becomes self-sufficient so that it doesn't have outside inputs anymore. You cannot grow the highest quality food if you have imported nutrients that you're mixing into the soil and creating a flush of loose nutrients in the soil. You can only do that by the biology having those life forces that arise at boundaries that are occurring in the environment there, and that's what feeds the plant life. And life is free. All you have to do is to see that you get those boundary phenomena working. In permaculture, this is called the edge effect. And it's a big deal. You're fertilizing with life. And life follows patterns, and they're dynamic patterns. Now, in biodynamics, we use preparations that we're taking manure on the one side and ground up rock powder like quartz on the other side. And you're filling cows' horns with this. And you're burying them for, might be the horn manure in the winter season or the horn silica in the summer season. And you're burying them in the earth for 6 months at a time.